So here is my schematic in order to turn on a three-phase AC motor. Um, the schematic or the circuit that I did is called direct online or DOL starter circuit, and is used to control and also to protect the three-phase motor. This schematic that I did over here is divided into two main sections, being the one on the left, the power circuit and the main circuit, and on the one on the right, the control circuit. Okay, so first I'm gonna explain the power circuit and or the main circuit. This is one that it's in charge to handling the heavy lifting, delivering three-phase power directly from the mains to the motor. First, we have the supply, which are these three lines over here, L1, L2, and L3. These are the three-phase AC power lines that are coming into the system and powering powering the motor. Then we have a three-pole circuit breaker, the one that is called QA1, and or that which basically provides a short circuit and an overload protection for the main power line. Then we have the main contacts, which are these ones KM1, and these are contacts of the electromechanical contactor. When the contactor is energized, these contacts close to supply power to the motor. Then we have these um, heating elements of the thermal overload relay, which are placed in series with each phase of the motor in order to monitor current draw and protect the motor from overheating due to overload or phase loss. Then finally we have the motor, this three-phase induction motor connected via the terminals U, V, and W, along with a protective earth PE ground connection, which is the one over here. Now I'm gonna pass to the control circuit, which is this one on the right. And this control circuit, in contrast with the power circuit, operates at a lower current. And this is typically powered across only one phase and neutral. In this case, I use an L3 and the neutral, of course. And this in order to safely manage the starting, the stopping, and the monitoring of the motor. This process can also be done including some automatization, for example, a PLC, which I'm learning to program right now. But for example, using a logo, 1200 and a 1500. So this control circuit as well consists of several parts. The first one that we have over here is the control circuit breaker, labeled QA2. And this just helps us protecting the control wiring that we have over here. Then we have some auxiliary contacts. The first one being the 9596, which is connected in series with the control line. And this helps us that if an overload occurs, these contacts open to cut power to the contactor coil and stop the motor. And then we have the normally open contacts, 9798, which close during a fault condition and they turn on a light of overload. That is the one that is connected over here. Then we have an emergency push button, which is a standard on the industry. And this allows us to do a manual shutdown of the control loop in an emergency. And this has to be restored manually. You cannot just stop it and reset. You have to reset all the system. Then we have a standard stop push button that is B1. And this is used to stop a normal operation. And finally, we have the SB2 or start push button that is used to initiate the motor startup. We have these auxiliary contacts that are wired in parallel with the start push button, 13, 14, that are connected directly or related directly with the KM1, the main contacts that we have on the power circuit. And these are act like a seal-in circuit once we press the SV2 or the push button, and which means that we don't have to stay pushing the start button in order to the motor to work. it acts like just like a trigger, and so the motor keeps working without us pushing the button. Lastly, we have this electromagnetic coil that, when energized, it physically pulls in all the associated main and auxiliary contacts, which basically means that when energized, the motor is going to start to work. Finally, we have this last part of the control circuit, which it doesn't directly affect to the functioning of the motor, but it helps us because these are indication lights and they provide a visual feedback on the system's operational state. First, we have the running active indicators, which are these ones over here, and they are wired to reflect when the contactor is active, signaling that the motor is running. Then we have this one, HL1. Then we have the HL2, which is typically wired through a normally closed auxiliary contact. This one over here that is directly connected to the main contacts KM1. This one 1112. And it will remain lit when the motor is stopped, so the operators know that the system is powered and ready. And finally, we have this HL3, which is a fault indicator, and it is connected to the thermal relay. Now, and it only illuminates when a thermal overload trip occurs. I'll do the most important part, which is the simulation of the system. I'm gonna play this simulation here, and so you can see what is happening. Here the loads are already powered, but they're not passing through any part of the power control. So I'm gonna close this circuit, and they're passing through here, but they're not passing the main contacts. Why? Because they're open, because they are not active. And here also we have the neutral line and the L3 line. And as you can see, the L3 line, which is powering the control circuit, it's not passing also. So I'm gonna close it over here. And as you can see, now the line is passing. And as you can see, the HL2 light has turned on, meaning that the system is powered, but it's not working. Okay, so here is the stop button. Here is the emergency stop button, the stop button, and the start button. I'm gonna press the start button, and as you can see, as soon as I press the start button, the three main contacts pass through, and the motor starts running, as you can see over here. Then I'm gonna just stop the circuit for a moment, and the HO3 light started to run again. If I do it again, the HO1 light starts to light in green again, and it's like a cycle. What happens if I press the stop button? Well, then it will stop automatically all the system. And as you can see, if I press the start button again, it will not work. I have to reestablish the emergency stop button for it to work again. And what happens, I'm gonna simulate a thermal overload over here on the thermal control by clicking it. And as you can see, the system stopped automatically, and the amber light HL3 over here started to light, meaning that there's something wrong with the system. And as you can see, since it detects a failure on the system, if I try to turn on the system again, it will not work. I will have to reset the system, and then I will be able to turn it on again, meaning that the circuit flows.